All right, welcome. Today we are going to tackle one of those classic aptitude topics that, let's be honest, trips a lot of people up, pipes and cisterns. But stick with me, because by the end of this, you're going to see it's just a puzzle, and it's one that's surprisingly easy to solve. So you see a question like this? Does your head just start to spin a little? Yeah, that's a pretty common reaction. I mean, you've got pipes filling a tank, another one emptying it. It sounds complicated. But what if I told you there's a beautifully simple system to solve it? We're going to break it all down step by step. So, here's our game plan. First up, I'm going to let you in on a little secret. This topic is connected to something you probably already get. Then, we'll meet the key players, the pipes themselves. After that, I'll show you one powerful method that can solve pretty much any problem they throw at you. We'll even put it to the test with some real examples and finish things off with some killer tips for exam day.
Okay, let's dive right in. The #1 secret to mastering pipes and cisterns? It's realizing it's not a new topic at all. Seriously, it's just time and work problems wearing a clever disguise. So if you've ever dealt with those, you're already halfway there. You can definitely handle this.
So check this out. This is the core idea. Just think of a pipe as a worker. That's it. The total work that needs to get done, well, that's just filling the tank up. And the efficiency of a worker, that's exactly the same as the flow rate of a pipe. Once you make that little mental switch, I promise everything else just kind of clicks into place.
All right, now let's meet the main characters in this whole drama, the pipes themselves. They basically come in two flavors, and figuring out their roles, that's everything.
So, on one side, you've got your inlet pipes. These are the good guys, right? They're filling the tank. Their work is positive. They're adding water. But then, you have the villains of the story, the outlet pipes, or, those sneaky leaks. Their whole job is to empty the tank, so we treat their work as negative.
And here's the bottom line. Every single one of these problems just boils down to a simple balancing act. You take all the positive work from the pipes filling the tank, and you subtract all the negative work from the pipes emptying it. That final number, that tells you the whole story. Is the tank filling up or draining out? And exactly how fast is it happening?
You know all those complicated formulas you might have seen? Just forget them. Seriously, there is one universal tool that makes pretty much every single one of these problems simple. It's called the LCM efficiency method. And trust me, it is a total game changer.
And the best part? The process is always the same. Just 3 little steps. First, we find the LCM of all the times they give us. This basically creates a perfect imaginary tank capacity that's super easy to work with. Step 2, we figure out how efficient each pipe is, how many units it fills per hour. And finally, we just add or subtract those efficiencies to see what happens when they're all running at once.
Okay, theory is one thing, but let's get our hands dirty, right? It's time to see this method in action. We're going to walk through a couple of classic exam-style problems, and you'll see just how slick this 3-step system really is.
So, let's start with the most basic setup you'll see. We've got 2 inlet pipes, both working together on the same team. Pipe A can get the job done in 20 minutes, and pipe B needs 30 minutes.
All right, time to apply the method. Step 1, what's the LCM of 20 and 30? It's 60, so let's pretend our tank has a capacity of 60 units. Nice and easy. Step 2, let's find their efficiency. Pipe A fills those 60 units in 20 minutes, so 60 divided by 20 gives us 3 units per minute. Pipe B is a little slower, filling 60 units in 30 minutes, so that's 2 units per minute.
And now for the easy part, step 3. Since they're both filling the tank, they're on the same team, remember, we just add their power together. So 3 plus 2, that gives us a combined filling rate of 5 units every single minute.
And the final step is a piece of cake. How long will it take? We just take our total capacity, that's 60 units, and divide it by their combined speed of 5 units per minute. And boom, 60 divided by 5 is 12. 12 minutes. Simple as that.
Okay, ready to level up? Let's introduce a little bit of drama. Now we've got an inlet pipe trying to do its job, but there's a leak at the bottom actively working against it. A hero versus a villain.
We're going to use the exact same method. The LCM of 6 and 7 is 42. So let's say the tank holds 42 units. Now, by itself, that inlet pipe should be filling 7 units every hour, right? 42 divided by 6. But With a leak in play, the tank is only actually filling up by 6 units per hour. And that difference, that's the key to the whole thing.
So let's think about this logically. If the inlet is pumping in 7 units of water every hour, but the water level's only going up by 6 units, where did that missing unit go? Well, it had to have gone out through the leak, right? So the leak's negative efficiency is 1 unit per hour.
So if we wanted to know how long it would take that leak to empty a full tank all by itself, it's simple. We take the total capacity, 42 units, and divide by the leak's power of 1 unit per hour. And there's our answer. It would take 42 hours.
Okay, now for a classic trick question you'll definitely see on exams. Alternating pipes. This is where the pipes aren't working together at the same time. Instead, they're taking turns, one after the other.
Now, with this one, you can't just add their efficiencies together. That won't work. We have to think in cycles. So let's map this out. With a 30-unit tank, Pipe A's efficiency is 3 units an hour, and Pipe B's is 1 unit an hour. So, hour 1, Pipe A adds 3 units. Hour 2, Pipe B adds 1 unit. You see the pattern? In every 2-hour cycle, they fill a total of 4 units. So to get close to our 30-unit target, we can run 7 of these cycles. That takes 14 hours and gets us to 28 units filled.
So after 14 hours, we're at 28 units. We only have 2 units left to fill. The crucial question is, whose turn is it? Well, the cycle is starting over, so it's Pipe A's turn. Now, Pipe A fills at a rate of 3 units per hour, but we only need 2 units. So it's not going to take a full hour, right? It'll take 2 out of 3, or 2/3 of an hour. So the total time is those 14 full hours plus that final 2/3 of an hour.
Look, the LCM method is your absolute best friend. It's reliable, it works for everything, but when you're in a timed exam, every single second counts. So let's look at a few shortcuts, direct formulas for very common, very specific situations.
So for 2 simple inlets, you could just do x times y divided by x plus y. For an inlet fading a slower outlet, it's x times y over y minus x. These are awesome for saving time, but, and this is a big but, they only work for these exact setups. When in doubt, what's our go-to? The LCM method. It always works.
So there you have it. You've got the tools now. You understand the pipes as workers idea. You get positive and negative work, and you have the incredibly powerful LCM method in your back pocket. So I'll leave you with one last problem to chew on. Just think about how you'd start to set this one up. The amazing thing is, with what you know now, a question that might have looked impossible before is totally, completely within your reach.